Let's take a look at how to start designing a connection either at CYPE Connect by itself or at CYPE Connect inside StruBIM Steel. The way to do it at CYPE Connect is either we choose a node from the list. Here we're going to do it for N27, which is one of the connections that we have left to solve from CYPE 3D. We choose a node of the list and we click here at the connection icon, or we can access that same window by clicking on this connection right here and clicking on whichever pyramid symbol, in this case N27, and we will come to this window. To do it at StruBIM Steel, we have to click first on the connection icon and then we click on edit and choose whichever pyramid. In this case we're going to click here at this pyramid. So from this is the tallest column at the left, and we are going to solve this one. So now that we are at the same window in both apps, let's take a look at, let me make this to you. So it's the same window, it's CYPE Connect inside either StruBIM Steel or at CYPE Connect by itself. So CYPE Connect is divided in 3 tabs. The first tab is the Model tab, in which we can design our connection with simple operations. Once we have it solved, we will move to the Analysis tab, which is this one, and then the third and last tab would be the Drawings part. Here in the Model tab, we find that we have a work area with a 3D representation of our connection or whatever we have so far. This operates exactly the same as the work area in CYPE 3D. We have here the projection. Then here in this menu bar, we have the single operations that we can insert to start designing our connection. If some of these operations, of course, we're not going to use during the training, so we recommend to check out the learning resources of CYPE Connect to see what each one of these connections can do. Then we have some editing to view options. We're gonna comment them in a minute, the measurements, and here we have a library which is going to be very helpful. So once we solve our connection or design it, we can export it to our own library to have it for other times. And here at the left there will be a list of the operations that we use for the design of this connection. So without further ado, let's solve or try to design this connection between V1 and P1. And the first thing we want to do is actually extend V1 to at least this face of P1 because it's not long enough right now. So for that, we're going to use this adjust bar operation by clicking here on V1. The bar we want to adjust to P1 to the farthest face, and we are going to complete this operation with a displacement of 150 millimeters. So this way V1 doesn't only reach the node, but it extends a little bit farther. Let's complete this design by creating a front plate for P1 to be joined to V1. So for that, we're going to choose this end plate operation, and here we find the section selection, which is going to be P1. We want to join it to V1 to the nearest face. Then we come here and we can select the material. For example, I'm going to use S275. If you want to know the materials that are here available, where do they come from, let me accept just for a minute to comment on both the code selection, which could be done right here with the earth symbol. For right now, we have selected for steel, timber, and concrete the Euro codes. And the materials will be found out that are going to be displayed in the operations are whichever materials you have previously defined here on this project library. So here we find the materials for the sections which have been described here. You can of course create more materials by adding them or edit the ones that are already inserted. And here in elements we can also create, because we will see it with this front plate operation, that we will need bolts, and whichever bolts we have described here is what are going to be available at the operations. So I thought we would make that explanation. Okay, so we were at the front plate operation. We had selected the material for the front plate. Now we're going to select the geometry. This plate is going to be 10 millimeters of thickness, and to better see the overhangs that we're going to choose, I'm going to change the projection to X and Y projection. This way we can clearly see that we could start trying to measure what length is left from the column or the plate that we have generated to the end, but sometimes it's even a thing of inserting and looking if it's right or not. So here we have, for example, an overhang of top of 15 and bottom of 15 too, and here 35 to the left and 35 to the right. So we have the base plate looking something like this. By the way, if you have noticed, the work area, whenever we place the mouse over any element, it displays the information that it has about that. So it's a BIM model. It contains information, and sometimes the dimensions of these sections can be important for the operations. So, for example, the width of this flange could have been important, as well as the total depth of this other P1. Just know that the information is there available, and this front plate is it's a complex operation. It comes with the geometry of the plate, the bolts, and the welds. So the next step we have to comment is the bolts. There are three ways to insert the bolts. First one, and we're not going to use it this time, is to generate a polygonal. So we choose the number of sides and the radius, and it creates the bolts according to that polygonal. Then next is here generate rows and columns. For this type of inserting bolts, I think, or for me, it is kind of helpful to know this information. So here in the edit menu, we find the view options, where we can actually make see through these sections and ask to display or not the excess of the plates. So I'm going to ask for the sections to be see-through and the excesses of the plate to be visible. So we can now see, whenever you are in this other window trying to generate the bolts by rows and columns, here we have where is the x x-axis in this plate. The way we're going to actually insert our bolts is going to be manually. So the third option would be, of course, adding the bolts manually. Here is a bolt at 0, 0. We could select, for example, 75. I'm going to insert to 4 bolts by clicking here on the copy this operation. So right by the add option, we have the copy, and by copying I'm going to change the numbers a little bit so we can start creating all the bolts that we need. Another way, if you have an Excel sheet in which you have these coordinates already inserted, you can copy them from the Excel and then paste them from the Excel. So now that we have our bolts, let's comment a little bit that the categories were pre-stressed or not pre-stressed, and the types would be according to whichever type you have described at the library we previously commented. And now the execution is a very important part both of the bolts and the welds, especially if we're speaking about StruBIM Steel. It all depends on if they're bolted or welded on site. If the pieces are going to come as an assembly to the site, or if they are going to be individual pieces. So here we're going to say that these bolts are going to be executed on site. And now moving to the welds, we can click here to add parametric welds, and I know these types sometimes generate doubts, so this first step is choosing whether you want the bolt to be in both sides of the element, or if you just want it in one. But I have found that the best way to know what these parameters mean is by generating an individual weld operation, not inside the front plate but another one, because here you can consult by clicking on this icon the information of these parameters. So you will see that the first step is of the welds is also whether that is executed on site or at workshop. So let's delete this weld. I just inserted it to let you know where you can consult the information about the welds, but very much they should be welded, at least these ones should be executed at workshop. So no flag, because the flag means they're executed on site. And with very simple operations, we have designed this very simple connection. And we'll see in later videos how to analyze and create a drawing for this connection.